And today we're going to talk about exploring design patterns, okay, for data pipelines. And I call it data pipelines because um, data is now not only in Azure Data Factory, but also in Synapse, right? So I'm going to share my screen, and that way I can start the presentation, and I'm going to stop my video, so hopefully we can save some bandwidth. Again, I really appreciate you spending the evening with me. It's very early morning where I am. I am in the US, and it's very cold. It's about 12 degrees. So I'm going to give you some links to look at later. Right now, this is based upon the Azure Data Factory design patterns. It's my GitHub. So if you go to John Minor 3 community work, you can get everything there. I'll be posting a new one because there's some new information I put here. So I updated the talk. Um, Second thing is, if you're curious what I'm doing, I am a MVP. So if you go here, I don't know why this page is not refreshing, but you can find out what I'm doing. This is my bibliography as well as whatever I'm working on. So I'm usually writing for MS SQL tips or presenting to user groups. These are the different articles that I've written for MS SQL tips. I'm going to focus on 3 of them that are really good background information. So there is Azure Data Factory parameter-driven pipelines, okay? And we're going to go over the data, there's examples in this talk. We're also going to go over how you can use, the self-hosted integration runtime to do on-premise data sources to the cloud. And we're also going to talk about supporting multiple file formats, okay? This is the actual interface that we're going to get into eventually, but this is the actual Azure Data Factory, right? And we have the pipelines here. So, and last but not least, we have a storage container and we have the output. Okay, so everyone is either working today with a data lake or they're working with an ODS, right? And so an ODS is an operational data store in a database. And so let me see if I can do slideshow and make sure I get presentation view on, and then we can talk. So how I'm going to break this down is I'm going to talk for a while on the slides. I need to give you a bunch of background information, and we're going to dive deep into some examples, okay? So again, if you need to reach me, John.Minor@Insight. I work for a company called Insight, and I'm a senior data architect. So technology, terminology, should I say. What we're doing is just moving data. I sometimes call myself a data janitor because, we're moving data from one place to another. But the movement data can be defined with a series of steps, right? And it really hasn't changed. I mean, obviously, the technology of where it's going, is in the cloud, is on premise, has changed. But the ideas behind it, have gotten refined. They're, before we used to run a program, say, let's go back to the days in which I wrote some COBOL, say, at a bank, right? And you'd read up data and you'd write it, right? And you would translate it, you'd make changes to it, right? And that's what we're going to talk about is these pipelines are ETL. Now, when you design a system, you can have systems 2 types. You can have it tightly coupled or loosely coupled, okay? The problem with a tightly coupled design is that any changes upstream, like the producers, will impact the destination, the consumers, okay? So we don't want tightly coupled systems. We want loosely coupled systems, okay? And with a loosely coupled system design, basically, only small section of the system needs to be redesigned if we're going to change something, okay? So for instance, we're putting data, and I'm going to show you the next diagram. It's called a hub and spoke design. So and each of these is spokes, but you can call one on this left side, say a producer. So say we have SAP data here, and we're writing it to a hub, and we come up with a dimensional model in the hub, and it could be either, a operational data store. So this could be, say, Snowflake, which is a leader in MPP, or Synapse, right? Or it could be Spark, which could be Synapse again, or Databricks, okay? But regardless of whatever technology you're either using some type of relational database to store your data, or you're trying to use some type of data lake to store your data, okay? And if you had this SAP and you decided, oh, well, SAP is not it's too big for us. We're downsizing. We're going to go to Microsoft Dynamics. As long as you define the customer in your data lake, okay, and most people are using data lakes now the same, that you could replace this as long as you map it correctly. The rest of the system, say a Power BI report, you can meld the data from SAP and Dynamics together, okay? Obviously, it's going to take some work, but that's the idea, is that you want to create loosely coupled systems. So let's focus on the data lake because that's where most people are working nowadays, and we're going to talk about how you can write pipelines to work with it. So there are two types of file formats in a data lake. Weekly type file formats can lead to data quality issues, okay? And it can also lead to broken pipelines, okay? So let's talk about a comma separated value file format. The way that works is that each column has some data. You have a comma between the columns, and at the very end, you have a carriage return. Okay. What happens if the columns have carriage returns themselves? Now we've broken a format. And recently, I'm writing an article on Wrangling data flows, which is part of ADF, which uses the M language, and I came across that same fact. Okay, it broke. What did I end up using? I ended up using a strongly typed format, okay? And why that's better is because you don't have to worry about such things. So for instance, go back to the CSV file. I have a ID, say social security number, and I'm trying to figure out, hey, is it a number or is it a string? Now, you live in a different part of the world. Your identification number may have alphanumerics in it. Mine in the US only has numbers, okay? So let's say I wanted to know if it was a string or an integer. How would I do it with a CSV file? I have to read up the CSV file, say in Spark, and scan the whole thing to figure out the actual schema, okay? A better way to do it is Apache file format, okay? This actually stores everything as binary. It already has the column name, so we don't have to read the first line and parse it into column names. It also has types. Last but not least, it allows for compression and it's splittable, okay? So again, when you actually put things into the data lake, think about the file formats you're using. Stay away from weak type file formats. They're gonna cause you problems. Go with strong types. Um, Databricks has been a leader in the Spark area for a while, and the reason why is the founders actually worked at UCLA, and they actually came up with Spark. Okay, so that was one of their PhD theses. About 2 years ago, they came out with something really exciting called the Delta file format. And then what it does is it uses Parquet files plus some logs. Okay, now why do we want to use a Delta file format? We're not going to go over it today, but if you look into it in Databricks, it's very easy to create. One of the things it allows you to do is ACID. So you get the atomic, consistent, independent, and durable transactions, okay? It also gives you snapshot isolation. So you can have readers and writers, but they don't block each other. You can enforce a schema. So you can say, hey, I don't want schema drift. I always want the same type of schema. Because we're doing logging just like a database, it allows something called time traveling. And again, that's governed by the settings of the Spark engine. So you can tell it how many days that you want to keep. You can also say you didn't want to keep any days. You could vacuum it and get rid of it, okay? It's an open source format that Databricks did, and it's built for distributed systems as Spark. Let's talk about the data lake itself, okay? So again, we can see this little icon here is a representation of the Delta file, okay? And on top of a Delta file format, we can put a Hive table, and the Hive table makes, okay, the text files or the Parquet files, and again, Parquet is the preferred format, look like a regular table. It gives you those ACID properties. You can now select from it. You can insert and so on. This picture is from Databricks, but we can see that this is an example of Lambda Architect, okay? And Lambda architecture has two concepts. You have a fast lane and you have a slow lane. So slow lane is a batch program. It runs once a day. Say we read from, again, the SAP and we put some data in the bronze, and a lot of times the bronze is called the raw zone. And what we can do is we can write a file there, okay? And that file is the raw data, okay? But say the data needs to be cleaned up. Say like I'm doing Super Bowl, and that's the example I use for the Power Query article I'm writing. In the Super Bowl, at the very end, they have a subscript and then say it's unwanted data. So we need to do some cleanup, right? So what we're going to do is we're going to run a program. It could be a Spark program, could be whatever program language you like to do, that will actually transform the data and bring it to the silver zone, okay? Now we have something called refined data, okay? But now say, let's go back to the VentureWorks, okay? Because VentureWorks is a very popular database example. I'm going to use it today. And say we have a VentureWorks data, and guess what? We want to flatten it to do reporting, okay? And the reporting is going to be a Power BI. So we might write a program to say, hey, show me all the sales for this month. Last but not least, we could run that program and create data in the gold zone. And a lot of times this is called the curated data zone, okay? Curated data. So again, the architecture for a data lake has the ideas of quality going across. Second thing is we talked about batch maybe run once a day, but we can take the batch and actually have it semi-real time or almost real time. So say we run it every 5 minutes. So now the data is more up to date. It's not exactly instantaneous, okay? Last but not least, streaming is the process in which you actually read stuff, and you could use like an Event Hub and Stream Analytics to write to the data lake, and that would be real time, okay? So again, that's the parts of the Lambda architect. There's two lanes, a fast and a slow lane, and in the data lake, there's different zones for quality. So when you bring data from whatever system into a data lake, you have to think about two things. What's the size and what's the so that's usually volume, right? And you also have to think about velocity, how fast you have to do it. And that's like the frequency we talked about, right? So when you have a small data set, and that's why I'm going to highlight this word small size data set, you can do a full load. And a full load means you could just drop the target data set and reload, or you can just move it and rename it, archive it, and so on. When you get larger data sets, what you want to do is, I don't want to bring 4 TB to the cloud every day. I want to bring a small subset, and a subset could be, say, for a given time period, could be a daily update file. And this could be really good for a, small to medium sized data. Not something that's teeny, but, I call small, maybe, several gigabytes or whatever, would be the incremental file. When you get larger data sets, now not only do we have to do incremental, but we really should start thinking about partitioning, okay? Because we're not always looking at the data from, say, we're getting daily sales, okay? And the daily sales is from Amazon.com. That could be really large in size, right? So we would probably want to partition it by day. But even by day, that might be too big, right? So we might want to partition it by the region which it's being sold in, okay? So again, when you use the largest data sets, not only do you want to do incremental loads, but you want to think about how you're going to partition the data for quicker access. Okay, let's talk about Azure Data Factory or pipelines, right? And regardless of whether or not you're talking about Synapse or you're talking about Azure Data Factory, right? They are based upon the same thing. Synapse stole most of the code from Azure Data Factory, and it's using similar engine, okay? So it was designed in 2015 is the first instance it popped out, okay, in the summer. And it's considered ELT. And why do we call it ELT? It extracts some data and loads it. And that's done with the copy activity. Last but not least, it does a transform. But were transforms initially part of Azure Data Factory? And the answer is no, okay? They were actually, you have to use something else. And we'll get into that later. The second version of ADF was released in the summer of 2018. Okay, and this became really popular because it had a ton of connectors. It's used for orchestration, so scheduling, right? I can say copy from on-premise to, the cloud. I can run a job to, say, a Databricks job to clean up the data and so on, right? And it allows you to combine legacy and modern environments. In the fall of 2019, Microsoft was working with Databricks and they said, hey, you know what we had on premise was SQL Server integration services. And that allowed us to do this like drag and, configure different transformations. We'd like to have an ETL, and this is wrong. And so extract, translate, and then load, okay? That means we can do the transformations in ADF without having to use a third party to do the compute, such as like SQL Server with stored procedure. So we could copy from on-premise to a staging table and then run a stored procedure. That's one pattern. And another pattern, say, to run something like a Spark engine, okay? And so this was the first introduction of ETL into the cloud, okay? Wrangling data flows leverage Power Query. That's popular with Power BI. And nice thing about Power Query is even less complex than trying to do SSIS, okay? Or mapping data flows. So let's get at the heart of what most people use, right? I've written a ton of programs using the ELT paradigm, the design paradigm. And we want to talk about design patterns today, okay? So the copy activity is the center of attention using this design pattern, okay? The data is moved from a variety of sources to a variety of destinations. And like I said, we have to use some type of external computing because we don't have it, okay? ADF naturally did not have it in version 1.2. So both SQL Server, like I said, and Databricks or Spark are popular computing endpoints. Let's talk about the objects and how you draw them and how they're built upon in Azure Data Factory or Synapse. First, you need a link service. What is a link service? It's just basically the connection information on how to connect to a data set. Second thing is, say we set up the connection information to connect to a SQL Server. Okay, great. But there's a lot of things in SQL Server. Am I looking at a view? Am I looking at a table? Am I pulling it? Am I writing it? So on. So we have to create the data set, okay? And the data set defines what we're going to work with. Activities are like the copy activity, store procedure, execute Databricks notebook. Those are things that allow us to do the work, say maybe remove a file. And guess what? Now we combine all these activities with the data sets and we make a pipeline. A pipeline is a unit of work that we can schedule. Nice thing about this is there's not only these, but there's two other things you want to add to your system when you do it. Triggers are used to schedule those pipelines on some type of trigger in some type of schedule, and alerts can be defined to say, hey, if something fails, notify someone. And you always need notification when you design a system because, no one ever writes the best program. I mean, you do as good as you can, but there's always the chance of failure. Okay, let's talk about hybrid data because a lot of people have data on premise as well as in the cloud. And how do we do that? Well, Azure Data Factory under the hood, okay, has something called Service Bus. So when you run a pipeline, it throws a message on Service Bus. Now, Service Bus, okay, where the message goes determines how it runs. So if I say throw it on Service Bus and I'm using an integration runtime that's self-hosted in Azure, okay, it's the auto-resolve engine, that it's going to pick it up and it's going to first, compute dispatch activity. So it's going to figure out how to connect to the source and destination, and it's going to do the data movement, okay? If we go ahead and do it on premise, what we need to do is we need to install a VM, and the VM can be either in your data set and run the data across HTTPS, or it could be on ExpressRoute. It's more secure because the packets are now on a backbone that don't go across the public internet. Last but not least is that the location of this could be in the cloud, even though it's connected on premise with the ExpressRoute, and it depends upon what type of peering you're doing, right? So if you're doing private peering, then that means you got a channel from on-premise to this VM here. And so this VM, as long as it's domain joined, you can actually talk to on-premise from the cloud. So there's many different ways to set up a hybrid data movement. I'm going to show you how I did it in my own demo area. Okay, so there is a ton of activities. I just cut and pasted them from the GUI that you can do. The ones that we're going to focus on today are the copy data activity. Okay, that's the most important. Okay, we can also, in the future, if you wanted to, do the T, okay, you can do a stored procedure, okay, or you can do a notebook in Databricks. Those are the two popular ones. There's also a Synapse connector that in this data hasn't been updated. Some things that deprecate, and I don't even know if they're around anymore, is USQL. So if you look here, USQL is going away. It's gone away, I think, in 2 years or something like that. You can look up the details. And an HD Insight is being replaced with Spark and Databricks. Okay, so now we're going to get into some demos. So we're going to talk about hard coding versus notebook parameters. We're going to talk about supporting multiple file formats. We're going to talk about supporting on-premise data set with the self-hosted integration runtime. So those are the 3 objectives. So I have this virtual machine, and this virtual machine is connected to the cloud. And one of our data sets is going to be the VentureWorks Lite, okay, data mart, okay? So we have some data here. We have an address file, we got a customer file, we have products, and you can combine all this into one type of product, but it's, you know, broken down into normal form. And then we have the usual sales header versus sales detail. Now we're going to minimize this, and we're going to go to the cloud, okay? And we're going to delete some directories. So these are the directories that we're going to create, and they're in a container. It's a bronze zone, okay? Delete, yes. Okay, so now we have a clear data lake. Okay, let's talk about hard coding pipelines, okay? So this one is going to copy a table to a CSV file. It's very simple, right? So we can look at it, and the thing that I want to point out is what I see most people now do, and it's very important, is first to put the timeout. Its default to 7 days. You don't want that. You want to set it to a time that is reasonable, right? So I'm going to say copy a small file in 5 minutes. That's probably even too much. We can also say how many times you want to retry the pipeline before it really fails, right? So it could give you a failure, but you know, maybe we have problems in certain time of day doing something. We say, hey, do one retry and it suddenly works. Now, when you do the copy, there's 2 things you need to worry about. You need to worry about a source, okay? And you need to worry about a destination. They call it a sink, okay? So let's look at the ASQL AdventureWorks Lite, right? So we're going to go into data sets, okay? And we see the ASQL Lite. And so we can see it's defined and it's hard-coded right now to a table. There's no parameters, so it's not parameter driven, it's hard-coded. And if we look at the ASQL, you know, link service, and again, you can see I'm using notations, right? PL for pipeline, DS for data set, and LS for link service. If we go to managed, okay, we can see link services, we can see where things are going, right? So if we look at this AdventureWorks Lite, we can see that it's actually going to a cloud database, okay? And that's one type of data source. We're also going to work in later on an example to show you how on-premise works with that VM I showed you. And that VM is connected to a runtime, okay? And that runtime is pointing to that same server. It happens to be that I put the self-hosted integration runtime on the same database server. It doesn't have to be that way. It's also parameterized. We can give it a database name. And we have some credentials here. And the credentials, when you set up credentials and there's a possibility that you can't do like a managed identity, which is like a service account that Azure's actually maintaining, then what you want to do is you want to actually use your username and password, but you don't want to worry about having to change the information every time it changes. And say if you get a bunch of connectors or a bunch of systems that are using this information, so a better way to do it is to use Key Vault. So Key Vault's being used in this design too. Okay, so now that we have the data sets, right, we could go back. One thing I always love doing is testing it, right? It says, hey, I do have connectivity. If we hit the preview, we get some data, okay? So let's talk about the copy. What's wrong with this one? First is that right here, we're not even specifying it. So it's not dynamic. You can't suddenly say, hey, use another source or destination. Second thing is, guess what? It's hard coded where it's going. It's going to go in bronze design 1, so design pattern 1, sales LT, and we're just going to drop an address file. Okay. So if we go over here and we run it, we hit debug, it's going to spin it up. We can see that it's going to look for a self-hosted auto-resolved. So let's get this right. Auto-resolved engine to run on it. And then hopefully we can find some compute. See, the auto-resolves showed you that ran under it, ran US East 2. There's always a pipeline run ID, okay? And we can see that it's successful. And one of the things that I always like doing is that everything in Azure Data Factory is a JSON message. So we can look and we can see that, hey, you know, we're doing a tabular transfer translator, and I have a whole article on that in which you can do dynamic mappings. But we're not actually mapping any data. It's just saying, hey, read from one place, write to another, and adhere to whatever data types we have, right? And if we're interested, we can do output. It tells us how many rows written, how many read, right? Files written, if it was parallelized, how long it took, the throughput, all that fun stuff. And then if you're curious, you get a graphical picture of the same data, okay? So let's take in the data lake. So if we hit refresh, again, storage count, and the storage count is a storage container, and I got a bunch of directories, but in the bronze zone, right, we look at design one, we can see is the sales light model, and we get an address file. Okay, let's talk about issues. First issue is this can get quite unwieldy, right? Because we have a ton of files. Second thing is we're not actually keeping track of versions, right? And we might want to keep track of versions. So let's try to fix that in the next design pattern. So next design pattern is we're going to actually use some parameters, okay? So this one, this design pattern, we were going to pass in the schema name. We're going to pass in the table name. We're also going to give it a zone, so bronze zone plus a directory. We're also going to tell it a file type, okay? So now if we go to the source, we can see now this is using the same connector, but we're actually using the expression language to come up with dynamic SQL. We're saying basically select star from the schema dot table name, and it's more dynamic, okay? Let's talk about sync. Same thing. The directory name is the zone name plus the schema name, and then the pipeline name is the table name. Now, what was wrong with this? This was hard-coded and it's only good for one table, right? If we had to do a second table, we have to change the dap to make a copy of it. We have to change the location, hard-code it again. Well, this version now I can go ahead and I can make multiple calls to it, okay? So I want to copy over, okay, the address. So now you can see execute pipeline copy address. I can do the same call, but do customer, so on. So now if we execute this, we're going to bring over a ton of data. We hit refresh. Now, let's talk about parallelism. We can see that how is this going to execute? We have these execute pipelines. So this one, because there's a precedent between this one, and you can say on failure, on success, right? It's going to say we have to finish executing this before we execute this, okay? So if we hit refresh, okay, we can see that we have two streams in parallel running. So one of the things you have to worry about is the compute, especially if you're on self-hosted, because there's only so many threads you can run these on. And that's probably a whole different talk on how to optimize that. But I chose to, knowing that it wouldn't overwhelm anything in the cloud and it's small data and it'll eventually get done. We can see that the bubbles are going here with green, so we're going down, the two are executing. And so if we count 1, 2, 3, 4, 5, we probably were dropping 10 tables, I think. And so now we go back to the data lake. We go up one, we hit refresh, and we go design, sales LT. Hey, this is a better design now. So before we had everything in one place, but we couldn't easily find it. Now we have a directory for each one. Not only that, it has a timestamp on it, right? So we can always look at the most recent file. One of the things I'm going to do is I'm going to run this one more time, okay? And hit refresh. And I'm going to talk about a problem that I didn't solve here, but I'm going to let you play with. The nice thing about the current one is it's doing the timestamps, okay? And it's using, whoops, wrong button. Sorry. Let's go here. But look at this. There's two things that I see problems with. First is that if we went into this directory, how do we know what's the most recent one, right? We're doing a full copy, okay? So we're not doing incrementals here. And I'm not going to get into incrementals today, but it's an easy pattern to solve. But one problem we have is now duplication of data, right? So how do we know what's the most recent file? One way to do it is we could just move this to an archive directory, leave this as a top one, and have our code in Databricks just pick up the topmost one and create a table out of it, right? A delta table. So that's one thing to look about. Second thing is we're only using a CSV file. We talked about CSV files being fragile. So how are we going to fix that? Okay, so we're going to go to the next design pattern. Okay, the next design pattern, okay, and again, is actually going to do if-then connections. So if-then is a design conditional pattern, right? It allows us to say, hey, if I say do delimited, right, then guess what? I can drop a delimited file there. If I say, hey, I want Parquet, I can do Parquet. Now, does this magically do it? No, it doesn't. But what we need to do is we need to put a if-then statement in for each of the file formats we want to allow for. So I'm going to allow for delimited. And I also, it could be, if I delimit it, I could change the extension to txt. So now I'm adding more parameters. And it could be not just a comma, but pipe, right? So I could put a pipe delimit, okay? We also can do Avro. Awk, which is a different file format compared to Parquet. It could be JSON too. So there's certain formats that, and I think I saw Parquet somewhere. So delimited, JSON, Avro, Parquet. There we go. So we have one example here. Let's just run it and let's talk about what's wrong with it, okay? Okay. Wow, that's interesting. Did we see what happened? Well, we ran everything, but because we do not know which one we're going to actually execute, right? It has to evaluate all the if-then connections. Not much extra overhead, but there is some overhead because we have to say, hey, is it an Avro? No. Is it an awk? No. Is it a Parquet? No. Is it a delimited? Yes. And then write it, or is it a JSON, right? Now, if we go back to the directory, right, and go up one and hit refresh, we have design, sales ST directory, and we can see a CSV file showed up. Okay, that's great. How about if I want to change it? Well, is that really hard to do? Not really with this design pattern. So now we knew that Parquet is there, and how does the underneath work, right? So let's pick Parquet, good strong. And what's going is, if you look at this, it's looking for the word Parquet. So I'm going to copy this, and it says to upper. So it's going to take whatever we pass to it and make it upper. So now I'm going to change this to Parquet. And I want the extension to be lowercase because I thought everything was there lowercase. And you know what? This doesn't really need to be there. Okay. And so I could just put a space there to say, hey, make sure it doesn't blow up. And now I'm going to run this. So again, we have the same pattern, which it skipped all these, and now it hits the Parquet, right? We can see it's picking up the right one, which is great. And if we hit refresh, it finishes. If we go here and hit a refresh in the directory, we get a Parquet file, okay? So now we're supporting multiple file formats. Not the best way though, okay? So we'll keep on, you can see each of these patterns is getting better and better, right? So close and discharge. Okay, let's talk about how do we work with on-premise data, okay? So what we're gonna do is we're gonna do on-premise data, okay? What's a better way to do it? Well, there's two refinements we want to do. First is because last time we did if statement, we have to evaluate each and every if statement to figure out what we're doing. If we use a switch, it's automatically going to look at the actual tag that we bring in. That switch statement says, hey, this is the value that I want to switch on, and it's going to find the case we want. So guess what? It's going to run better because we don't have to do those additional ifs. It's going to run one activity. Second thing is that we can see that if we go back to here and go to parameters, right, this one, we can see that there's a lot of stuff here. But say I want to support the tabular translator, which is a mapping document. Well, I have to add another parameter. Then I want to say support, I don't know, whatever format. I keep on adding parameters. We can see this gets quite lengthy, and we can get really confused quickly, and it's hard to, understand what's going on here if we keep on adding parameters. A better way to do this, okay, is to actually use a dictionary and JSON, basically a JSON document. So JSON document is a key value peer, and we can see now that I can go ahead and say, hey, do VentureWorks, LT, address, zones bronze, right? And again, in our example, we'd want to change this to like design 3. And then this is doing a ORC. We could do say a parquet, right? And then another parquet. And now, guess what? Instead of passing a ton of parameters, there's a little setup on our side in which we have to put this into basically a document. Now, you can see readily that the next step would probably be putting this into a table and doing a for loop with some conditions, okay? And that's called table-driven, okay, design, debug. So we're gonna kick this off. Hopefully I didn't make a mistake on the document. That's the only place I could make a mistake. Now we can see it did a switch. It's small enough to say, hey, I want to do a copy to parquet. It's running the command that's inside the switch on the actual case that was hidden. And this one's taking a little longer, so maybe oh, why is this taking longer? Well, guess what? It's not in the cloud. This is actually going self-hosted integration runtime. So it's pulling from on-premise or pseudo on-premise data. Let's look at output. If we go back to Bronze Zone, we can see design pattern 3's there. We have the directory for sales, address, and guess what? We got a parquet file. So let's talk about how do you set up, okay, the self-hosted integration runtime. I'm going to go back into Azure Data Factory, went too far out, and we're going to go all the way down to manage and talk about it. And then we'll go to the self-hosted VM. So what is a self-hosted runtime? A self-hosted runtime, integration runtime, is just basically a VM that you install some software. So when you do it, you have to install a download from Microsoft, install it on there, and use a key. Once you set the key up, and if there is an access, there's some, ports that need to be opened, such as, for traffics, like port 80, and I don't know the rest of them. I assume it's probably maybe 443, but you can look it up. Once those ports are open, it will send HTTP traffic over the either public internet or the private if you're using ExpressRoute. But this is the piece of software that you need to configure, okay? And like I said, I put this software on the same box as my database, okay? So this is a VM for SQL 19, and it's pointing to my Azure Data Factory for tips I write for SQL's. I'm a SQL tip, so that's why that's there. And we can go into the database. So this is the cloud database, but we can see the local database. So we're going to go to VentureWorks tables, and we saw it took some more time because not only did it have to put the message out there, but then the software on the VM had to recognize the message there, read it, get the security, get the credentials to execute against SQL Server on-premise, get the data, push it back to the cloud, okay? But we have the same schema here in on-premise version as in the cloud. Maybe the database name is just a little different, but we have the same data, okay? So I talked about the integration runtime. I talked about on-premise data. Is there anything I'm missing? Don't think I am. One of the things you can do, and I want to show you, is that high availability. Say if you wanted to make sure that your system doesn't go down, you might want to put 2 of these up there. You can also see concurrent jobs. This is where you get CPU and you can bring it up. Also, you want to make sure that you have accelerated networking done on your VM, okay? So let's go to the last pattern. So we talked about so far this, right? And we're actually copying data. And we ran this once. How is this going to on-premise? Well, we talked about the link service, so we're going to go back to here. And we can see that MS SQL VM 19. How was that set up? Well, instead of doing the auto-resolve, we picked the SHAR, which is the self-hosted integration runtime, and we passed the right credentials. That's all we had to do. And for the adapter, okay, when we create a data set, we just have to find it, and it's right here. And we can see now that we did, that's not the right one. It might just be this one. Nope, that's the storage. Right here. And so we can see this one is actually going to the link service, and then we parameterized it. So we got some parameters. We got the actual data set name here. And, you know, this is hard coded. Okay, and the last one, did I go ahead? How did we do this? Just want to double check. Source, so database query, database name. Okay, so even though there's a little trick you can do, is that even though this one is actually saying that's a table, and we could parameterize a table, when we actually do the copy, you know what we can say is we're going to overwrite it with a query, and that's what we did. And so in there, we're actually getting a string of the parameters of the metadata, right? Dot. So we do JSON of the string of the metadata schema names, right? And then we have to do the same thing for the table name, and then we concatenate it with the select, and we get the right select statement. Okay. So the last one is this one, in which we're going to go back and run it. And then I'm going to get back to the slide deck because I'm running out of time. We started a little late. So we talked about this is the pattern that allows you to pick multiple files, and it's going to read from on-premise to the cloud. This one now is a little different. This does the big data from admin mechanics. So we got a big product data and we got big product history. So we have 3 pipelines, and the calls are just a little different. We're going to call this new pipeline with the correct parameters. So I'm going to kick that off. Okay, we'll come back to that to wrap up our discussion. So we got the pipelines. We're not going to have time to do the demos. If it was like a user group and I had a few more minutes, I'd do the demos for ETL. Okay, so let's talk about the pros and cons of ELT. That's what we did. Most all components can be parameterized, so we saw that. So we can have like a master pipeline, like that one component, and then we can have a call to it, a generic pipeline. We can see that eventually this is going to get to a table-driven design in which everything can be put in a table, and that can drive our ETL. And that's smarter because now we have less components. We don't have to worry about calling them, and we can do scheduling many different ways. Okay. So with the ELT, transformations have to be done with either in the database with stored procedures or notebooks. And the notebooks could be any flavor of Spark, right? And it's going to be a data lake. Things you want to think about: execution of multiple pipelines in parallel to reduce the overall transfer times, right? We can also change the batch size in SQL. So how much do we send to the database before we commit? Or the cluster size in Spark, which is how many nodes we're going to use to work on the day and how we're going to partition that Parquet file to alter the execution performance and overall timing. So those are things to think about, and those are kind of like advanced topics. Let's talk about ETL, okay? And this is the other one that we're not going to have time to go into, but I'm going to talk about. The source and destination have to be in the cloud because the mapping data flow or the wrangling data flow is using the Spark engine, and it's using the Databricks Spark engine. I don't know if they've changed that over to Microsoft Spark engine, but that's what's being used. There are parameters support for data flows, but the problem is you cannot have a dynamic destination because it looks for schema drift. And because of that, we can't do the fun stuff we saw in the previous one. We have to kind of custom code a lot of things, okay? There's 16 additional transformations in a mapping data flow. It allows you to do the T. Wrangling data flows started in 2 years ago as a release and then recently came out. It's based upon the Power Query interface in M language. I like it. The problem right now is limited source types that are supported. Second thing is that the interface allows you to do some things that will not run on their Spark engine. Okay, it doesn't translate the M language correctly. And so if you know those limitations, you can use it. I'm looking forward to the product group fixing that product so it's ready for prime time. So let's look at the extract, translate, and load components. Now we have a lot of stuff that's kind of like when you looked at SSIS. We can take 2 data sets and join them. We can do a conditional split. That means take the data and split into 2 pipelines. And we can union data. We can look up data. We can add things like derived columns, okay, selects, aggregates, so on. And there's some other things like the source sync and new branch that are not part of this component. So let's go into the pros and cons of using this, okay? Regardless of whether or not you're using a mapping data flow or you're using a wrangling data flow, which is the M language, you still have to use a standard pipeline. You still have to define that source data set. You still have to define that destination data set. There's some other options that you have to worry about when working with Spark, like partitioning, batch size, isolation level, okay? Nothing you have to worry about is it does take time for the Spark cluster to spin up. Now, they fixed this, but one thing you want to make sure is that there's a time to live. So once it's spun up, you might want to say, hey, I want to keep that Databricks cluster around for an hour before it shuts down. Because otherwise, each time you run a mapping data flow, you have to wait 5 minutes for the cluster to spin up. Another thing is there's overhead to parallelism of a data stream. So when you do the copy activity, okay, it might be better than a data flow for small data sets. Okay, advanced lookup and transformation steps can be performed with data flows, which is cool. Again, let's do a cost comparison, right? A quick estimate. So last time I looked, and again, this is a while, you could redo it. I mean, there's a costing engine out there. I didn't do the cost of a virtual machine, which is a couple $100 a month with the integration runtime. And if it's on premise, then you don't even have to worry about that because you're already in your data center. But on average, it costs about $262 per month to run ADF. In Spark, guess what? If you're using data flows, you're adding an extra $1,500, $2,000 per month. So that's a consideration. I might have, if we have, we'll go back to this. I want to wrap up the slides. Look at maybe a wrangling data flow. It's something I'm writing about. I can go quickly through it and then call it a day. Summary, okay? Azure Data Factory supports 2 design paradigms. You can have ETL and ELT, right? ELT is the pipelines, activities, data sets, and link services. Basically, at the heart of it is the copy activity, okay? The cool thing is you have a multitude of sources and destinations you can do, okay? And the computing has to be done with an RDBMS, with a stored procedure, or with a Spark. Recently, Microsoft, within the last 2 years, added Databricks / mapping data flows and wrangling data flows to the design. So now we can do the T. Again, there's a bunch of transformations you can do, and then there's a end destination. So is there any right way or wrong way to create these processes? And what I want you to do is ask these following questions. Does the process accurately perform the data movement and translation of the data? If it does, then you've solved it, right? Does the process execute in a reasonable amount of time so the data gets there so the business line can use it? That's another question. And if it does, then you solved your problem. Some processes can scale, right? So if you think your business is going to suddenly go from 0 to 1,000,000 miles an hour, then does the process scale? And again, that's something that you have to define as a success criteria. And last but not least, does it meet your operating budget, right? So in summary, Data Factory offers many different ways as a developer to move and transform data. At the event slide deck, there's a bunch of things. Naming conventions are very important. I use N. Navin's WordPress document. He came up with something really good, and I use those. Pipelines, mapping, wrangling, and integration runtime, okay? So thank you for your time. I have 4 minutes, and I'm going to open up to any questions.
Actually, John, we are broadcasting this event through Facebook. So still, currently we cannot take any question.
Okay.
But it is quite interesting, and I feel it will be very much helpful for the audience. And personally, I am working on local ETL process, but I think we need to use Data Factory. But in customer side, it will be they are thinking about the concurrently the expense say Azure. What about the? I think I have a question in my mind that how much money will be recurrently they have to expense, say in a mid-sized company.
Yeah, so like I said, the ADF, if you're using Azure Data Factory itself, it's the lowest cost that you can get. But then you have to do the transformation somewhere else, right? So if you're going to that ODS, which is a database, then you can do that with stored procedures, and that's part of the database cost, and you already have that cost figured out. If you're not going that, then you can go with Databricks. And one of the things nice about Databricks is that you can tell it how long you want the cluster to stay up, right? So you run all your jobs and the cluster goes down. So you're not spending money for that compute, right? You're doing the same thing with Azure Data Factory or Synapse, but I think, like I said, I think the clusters nowadays stay up an hour so that you don't get that down and up thing, because it does take 5 minutes to start it up. But again, you can worry about that by doing concurrent. And again, you can write a big job in Databricks to do all your transformations all at once if you have that ability. A lot of times people want to do things in chunks and schedule it. And so this design pattern of like, hey, copy data and then call either the stored procedure or the Databricks falls into that paradigm, and it's really good.
Okay, thank you.
You're welcome. Hey, do I have 2 minutes, or is the next speaker here?
No, you can, if you want to say
Please go ahead.
Topics within 2 minutes, you can.
Okay, so awesome. So I wanted to show you 2 minutes what the mapping data flow, wrangling data flows look like.
Okay.
So, and it's an article I'm writing. You'll see it on MS SQL Tips pretty soon. So, how many people are in the US? A lot of people like Super Bowl, right? And so the Super Bowl is coming up. And so let's go to Wikipedia. I'm a Super Bowl fan, and I want to go to Wikipedia, and I'm going to type Super Bowl. Okay. So I'm such a fan, I want this data in my database for some reason, okay? And again, this is a contrived example, but we can see there's some serious issues here. There's carriage returns, right? There's a lot of extra characters we do not want. And say I'm a citizen developer in which I know how to use Power Query. How can I do the same thing that we're doing here? Well, if we go back here, okay, what we're going to do is we're going to do the final one, okay? And again, do not use CSVs with these, because if there's that bad data, you're going to have problems. So what we're going to do is we're first going to take the source, okay, which is the web page. And again, the article will explain all of it, and drop it to a Parquet file. Okay. Second thing is the destination, because Spark always writes a bunch of files. Okay. We really can't tell it a file. We're going to tell it a directory, but to clean up and make sure we don't get duplicated data, we have to clean out the directory. So that's what the delete's used for. This is actually the transformation here. So what I want to do is just show you real quickly what Power Query looks like. And so Power Query looks like, and I'm going to see if I can minimize this. It looks exactly like if you were doing Power BI. And it might take a little while to spin up, depending on if it's awake today, like I am. I need some more coffee. So one thing I want to point out right here is not all the functions are available. So if we did some functions that like if we took it and we split it on this delimiter right here, it's not going to work, okay? Now, what I do is I know a lot about the back end. I like writing code, okay? So what I did is I wrote all this in my own script, and that's why I renamed the steps here. Usually don't see step 1, 2, 3, right? So we can go to Advanced Editor. And Advanced Editor is, hey, we're going to read that Parquet file and we're going to get rid of anything that, is not to be determined. Now, the M language is functional, so we have to create like almost like a f of x, right? And that's what it is. Let all these, and it's built upon. So source is the destination, and then step 1's built on source, and then step 2 is built on step 1. So we're going to replace text, and then we're going to replace the 50, which is a wrong character, with an L, because they're supposed to be Roman numerals, and they made issues, and then more carriage returns. And then, we're going to go ahead and we go text position of a certain delimiter, which is the parenthesis, and we're going to get rid of it. So we're going to do truncation and so on. The main thing I want to show you is that this is the data before, okay? And then if we go to the last step, okay? And hopefully it's slow today. This actually runs on a Spark cluster, so it's still some online service, so it's thinking right now. Eventually, it's going to come up with the answer. And while that's working, I'm just going to go back to, did I get rid of it? Where is it? I did get rid of it. Dashboard. I want to show you the output. Storage count. And open Explorer. Containers here. And then if we go into bronze, this is where we're going last time. So remember we did the DBO with the big product and we have the Parquet files, okay? So that's that example. And then this one I think is under tips, under bronze and Super Bowl. And we can see we can do both the Parquet and a CSV. We can come back and we can see, guess what, it cleaned it all up. Remember, we had all this junk, now we have it all. And if we did run it, and I'm not gonna do that here because we're basically out of time, the destination is basically a SQL table, right? And so with this design pattern, you have to use, if it's a weird data source, like if it's not a RDBMS or a Synapse, you have to use the data lake as a between place to place the data, okay? So if we go back to the VM, I can show you the end result. And basically I did get my Super Bowl data, it's in there. So I think I put it in the cloud. And so if we do this guy, 22, come on. Problem with Azure SQL databases when they're like DTU 0, they seem to take forever. And I think this is a basic one. And so if this expands, you'll see my Super Bowl table and eventually the data will be there. So anyways, some exciting stuff. If you like Power Query, you know, there's definitely some exciting stuff coming down the road with Microsoft. So Ahsan, I want to thank you again for having me. I really appreciate you inviting me to talk today, and I'm going to probably go back to bed.